If you can dream it, you can build it. Dream of designing a device that will change our lives. Now imagine you can make it happen. Make it real. Make it fast and powerful. Make it intelligent and make it learn. Make it analyze and predict. Make it fun and creative. Make it look sharp and gorgeous. Make it friendly, user-friendly. Make it efficient and productive. Make it smart and connected. Make it prevalent and extensive. Make it secure and protected. Make it safer and autonomous. Make it sound clear and pure. Make it speak
and understand.
Make it free, truly wire-free. Make it sweat and stay in shape. Make it move and sense all around you. Make it grow and make it nourishing. Make it all happen with CEVA. CEVA licenses ultra-low power smart sensing and wireless connectivity solutions. CEVA's IP powers more than 10 billion devices worldwide. Dream it and make it with CEVA.
Will be Franz Dugand, who will speak about Wi-Fi 6, including the latest introduction of the Wi-Fi 6E in the 6 gigahertz range. So over to you, Franz.
Thank you, Moshe. So hello, everybody. Thank you for attending this virtual seminar. So I am Franz Dugand, Sales and Marketing Director for the Wireless IoT Business Unit, which include Wi-Fi, but also Bluetooth and narrowband IoT product lines. So as Moshe said, so today I will talk about Wi-Fi and particularly Wi-Fi 6E, which is a new addition in the Wi-Fi 6 as it allows to expand the Wi-Fi technology to the 6 gigahertz band, which is very interesting, you will see. So for sure, during the course of my presentation, should you think about any question, feel free to ask. There is a Q&A button that you should see at the bottom or at the top of your screen. So feel free to send your question about this Q&A box. Okay, so first I would like to talk about the Wi-Fi market in general. So this market is pretty big and still growing significantly, as you can see on this diagram. If you look back to 2010, the Wi-Fi market was already quite significant, but less than 1 billion devices were shipping at that time. Now in 2020, we expect that more than 3.5 billion devices will ship, and by 2024, it will grow and exceed 4.5 billion units. So it's significant, as you can see. For sure, this market is highly dominated by the cellular device, so the smartphone typically, which represent the biggest portion of this market. But not only that, Wi-Fi is now available in many different kinds of devices, not only cell phone, laptops, tablets, but also in IoT applications, wearables, smart home, etc. And as you will see in the next few slides. For sure, networking is important. These are the access points, and which are absolutely necessary to deploy your network. about, you may have heard about the initiative from the Wi-Fi Alliance to actually simplify the generational branding, the naming convention. Up to recently, when you were talking about Wi-Fi generation, you were using quite complex and esoteric numbers and letters like 802.11a, B, G, N, AC, etc. Very complex. And for the people who are not into the details, who are not technical people, it was difficult to understand which, sorry about that. It was difficult to understand which flavor of Wi-Fi was used, how fast it is, etc. So that's why the Wi-Fi Alliance decided to simplify everything and to rely on a number which represents the generation. So for instance, the Wi-Fi 802.11n is now called Wi-Fi 4, 11AC is Wi-Fi 5, and 11AX, which has been ratified last year, is Wi-Fi 6. So this is very convenient. And last but not least, they also introduced a way to identify the type of Wi-Fi connection you have. Until now, when you are connected to a Wi-Fi network with your laptop or smartphone, you were just seeing that you are connected, but you had no idea about the speed of your connection and which Wi-Fi flavor is being used. So this will change, and thanks to new icon, which will allow to identify the type of connection you have with the access point. So Wi-Fi 4, 5, or 6. So it's very convenient. It's a bit like the cellular communication with your smartphone. You know, if you are in 3G, 4G, 5G, you have an icon for that, and that will be the same for Wi-Fi. If you look at the Wi-Fi flavors which are being shipped, so it's interesting to see the market share for each flavor, and it's interesting to see how fast Wi-Fi 6 is actually penetrating the market. And actually Wi-Fi 6 is really the fastest Wi-Fi flavor to penetrate the market ever. As it will become dominant in just 4 years from now. So in 2024, Wi-Fi 6 will dominate the market and will actually replace not only Wi-Fi 5, so the 802.11ac, but also it will take some market share from the 802.11n, which is mostly used for low power application, IoT, etc. But there is a benefit in moving to Wi-Fi 6, and I will explain you why. If you look at some market breakdown, and to really understand how the Wi-Fi 6 is penetrating the market for each market section. So for sure, the smartphone and tablets will quickly move to Wi-Fi 6, and it already started. There are already some flagship smartphones which are supporting Wi-Fi 6, and it's progressing, and it will already become dominant in 2022, 2023. Same for tablets, and for sure, same for the networking, the access point. So here, you know, like in many other technologies, there are a kind of chicken and egg situation. For a new technology, a new wireless technology to be deployed, for sure you need the client, the device to be upgraded to support Wi-Fi 6, but the network as well. So all the infrastructure need to be also upgraded. And the good news is that both are going to be upgraded and in a very fast penetration rate. So that's really the good news of the Wi-Fi 6 technology. So not only the smartphone, tablets, and access point, but all other market segments are also moving to Wi-Fi 6. including wearable, IoT, smart home, home entertainment, etc. So all these markets see actually a benefit in moving to Wi-Fi 6. There are advantages, I will list them later on. And so that's why they are moving to this new flavor. A bit of history about the evolution of Wi-Fi up to now. Wi-Fi is now a more than 20 years old technology. It started in actually 1999 with 11B. We started to see some products at that time. I think probably Apple was a pioneer in this area and was the first to integrate a Wi-Fi technology into a computer. It was the iMac at that time. And that was just a replacement of the wired connection to internet to access your emails predominantly. Then in 2003, it moved to 11A and G with a higher throughput so that you could also browse the internet. In 2009, 11N got ratified, now called Wi-Fi 4. And thanks to the MIMO capability and so a significant increase into the throughput, you can do many different things, browse internet, but also stream videos. Later in 2013, 11AC got ratified. And here again, higher throughput, more devices can be connected to the internet. You start to see some mobile devices like smartphone and tablets supporting Wi-Fi and AC getting dominant. And then last year, so Wi-Fi 6 got ratified. And that's really breakthrough technology where many different types of devices can be connected to a network. You can have a high-end device with a high throughput and low latency requirement, coexisting with low power devices which have very low throughput requirements. And all these devices can coexist and can be connected to the same network, to the same access points. And that's really what made the Wi-Fi 6 technology really breakthrough. But last but not least, so this year, Wi-Fi 6E got introduced. You may have seen some announcements a few weeks ago about that. And that's another major step to increase further the capability of the Wi-Fi technology and to address even additional applications like, for instance, the VR headset, which were not possible with the previous flavor of Wi-Fi. Okay, so a few words about the Wi-Fi technology. So what is Wi-Fi 6? You may have heard about Wi-Fi 6 as high efficiency Wi-Fi. So this is really the main, I would say, feature. What differentiates Wi-Fi 6 from previous flavors. It's very efficient and allows many devices to be connected together in a crowded environment without impacting much the network efficiency and without impacting much the throughput which are required by each devices. So several features have been introduced. So I will list some of them, which I think are the most important. So the first feature is actually the new type of modulation which has been introduced, which is OFDMA. So until Wi-Fi 5, OFDM modulation was used. So that was great, high throughput, quite efficient, but not good enough for high efficiency. So OFDMA has been introduced, and that's basically a similar technology than what you can find in cellular, LTE, 5G. So this is the same kind of modulation, which allow much higher efficiency and reduce latency. Why? Actually, with OFDMA, you have the possibility to divide a channel into a smaller bandwidth. So in Wi-Fi, typically a channel can be 20, 40, 80, or even 160 megahertz. Until Wi-Fi 5, a device connected over Wi-Fi and transmitting packet over Wi-Fi was actually taking the whole bandwidth of the signal. That was not very efficient because in some cases, and in most cases, actually, you don't need the full bandwidth. You want to transfer some amount of data, even for HD video streaming or even 4K video streaming, which require roughly 15 to 20 megabit per second data rate. It's not enough actually to fill the complete bandwidth of the signals. So that's why it's good to have the possibility to split into smaller bandwidth, and that's what is offered by the OFDMA modulation. So you have the possibility to have several tens of devices sharing the bandwidth, and the access point has the capability to transmit simultaneously in parallel packets to all these clients, and vice versa. Those clients can also in parallel simultaneously transmit packets to the access point. So it makes the network much more efficient. And it also allows the access point, the infrastructure, to do the scheduling in a much more efficient way. Another interesting feature is called the DCM. It's a new type of modulation which allows to go longer range. So it's lower data rate, basically half the data rate, and which allows to go much longer range. There are cases where you can exceed 1 kilometer range thanks to that. So this is very interesting, for instance, for outdoor application where you have wireless sensors connected to infrastructures. They can be very far away from the access point or may not be line of sight. So that's interesting to have a long range capability. And this DCM feature is actually also available in some other Wi-Fi flavor like Wi-Fi Halo. And the exact same feature has been introduced here in Wi-Fi 6. Next feature is spatial reuse, which is based on BSS coloring. One drawback, if I can say, about Wi-Fi up to now is that in order to transmit a packet, a device first needs to listen to the medium. If the medium is free, the device will transmit the packet. But if it is busy, it will wait for a certain amount of time and then try again, listen for the medium until the medium is free, and so that it can transmit the packet over the air. It can be a problem in a dense area where you have several access points. And thanks to the BSS coloring, this is the way we call it, actually each access point has a color and an identifier. And so that, let's assume a device who wants to take the medium, it listens to the medium, it seems to be busy, but after further analysis, it seems to be busy with a packet which is being transmitted to another access point in the neighborhood. So in that case, the medium can be considered as free because the station doesn't want to actually communicate with the same access point. So it can send a packet to another access point in parallel. So it will improve a lot the network efficiency, particularly in dense areas like airport, for instance, when you may have different access points in an area. Last feature I wanted to talk about is target wake time, which is for power saving. It's very important, particularly for IoT wearable applications where the power consumption is critical for sure. And thanks to this feature, the device can negotiate with the access point specific times to access the medium. So it reduces a lot the contention between devices, and in between the transmit opportunities, the device can go to low power mode completely in order to save power, and then wake time, just wake up when it's time to transmit packets. So that's why Wi-Fi 6 is not only a good technology for highly demanding application with a high throughput requirement, etc. It's also a very good technology for low power applications. And so that's why Wi-Fi 6 can be a very good replacement from Wi-Fi 4. So bottom line, the benefit of Wi-Fi 6. So first, better efficiency in crowded environment. So after some statistics analysis, it turns out that each user will actually experience a 4 times better throughput thanks to Wi-Fi 6 when competing for bandwidth. So that's really good. Another benefit is higher peak data rate. So that's not the most important feature of Wi-Fi 6 compared to the previous flavors. It's just 25% faster thanks to the new modulation, which is 1024 QAM, as opposed to 11AC, which was going up to 256 QAM only. So it's just 25% faster, but thanks to the efficiencies, the OFDM modulation, etc., the user experience is 4 times better. For sure, it's backward compatible. So Wi-Fi 6 can coexist with all the networks, and this network will accelerate, will improve, will be much more efficient as the device gets upgraded to Wi-Fi 6. And last but not least, it's much more power efficient than previous flavors, and which is good to extend the battery life of user devices. So it's possible to have devices with extremely long battery life, even running on a coin cell during months or even years, depending on the use case. So is it enough? So Wi-Fi 6 seems to be very good when we look at all the benefits, but is it really enough? According to a study from Cisco, nearly 60% of the global mobile data traffic will be offloaded to Wi-Fi by 2022. So that's going to be a problem, and it's already starting. The 2.4 gigahertz band is crowded, and Wi-Fi is actually competing with other technologies like Bluetooth and Zigbee. And even so, that's why the 5 gigahertz band has been introduced many years ago, starting from 11A, in order to offload the 2.4 gigahertz band. But as the internet traffic is still increasing a lot, even the 5 gigahertz band got crowded now, and overflowing the capacity of the current Wi-Fi 4, Wi-Fi 5, and even Wi-Fi 6 because of internet increasing traffic. So there is a need for an additional bandwidth, definitely, to minimize the Wi-Fi traffic jams. So the solution is Wi-Fi 6E, which has just been introduced. So that's really the solution to the increasing traffic. So you may have seen some announcement from the FCC and the Wi-Fi Alliance, which just gave green light to the use of Wi-Fi on the 6 gigahertz band. So what does it mean? Actually, more than 1,200 megahertz of additional bandwidth are being freed for Wi-Fi. So that's really good news. It opened new channels, so you can have up to 7 7 channels of 160 megahertz each, so additional channels, while there were only 2 on the 5 gigahertz band, which also correspond to 14 channels of 80 megahertz each, and only 5 were available on the 5 gigahertz band. So this is really increasing significantly the total available bandwidth, and in order to sustain the increased traffic. So what are the target devices, target application which will benefit from 6E? For sure, the access points are being upgraded. Some of them already support 6E in the hardware, and so they will just require a firmware update to fully support 6E. And then for sure, the device that will benefit from that will be the laptop, smartphone, tablets, TV, gaming console, etc. So all those devices which require high throughput and may coexist in many other devices on the same network. So typically in an airport, an office, or even at home, where you see an increasing number of Wi-Fi devices. So the home devices like TV, set-top box, gaming console will benefit from 6E. And last but not least, the AR VR headset will also take benefit from 6E. And the main reason is that so there is an additional bandwidth on 6 gigahertz, so less crowded, less interference. Wi-Fi 6 and 6E data rate is good enough for VR headset, and the latency is also low enough for this kind of application. So today, the VR AR headset which are using wireless technology are actually based on WiGig, which is a Wi-Fi on 60 gigahertz. So that's a very good technology, but it's very expensive and power hungry. So clearly we start to see a trend, a demand for those devices to move to Wi-Fi 6E. At CEVA, we have a Wi-Fi offering for sure, and for all flavors of Wi-Fi, so Wi-Fi 4, 5, 6, 6E. We have been working on Wi-Fi since 2002, and it has been widely adopted in many chips worldwide. And today it's shipping in millions of units every month, and it's growing. So we have actually different flavors and different type of Wi-Fi IPs that we can offer to our customers. And to address different market segments. So we have low power Wi-Fi for IoT applications, for instance, so supporting 802.11n or AX, so Wi-Fi 4, Wi-Fi 6. We have a mid-range solution for handsets, smart home, TV kind of applications, and a high-end solution for access points infrastructure, so dealing with a 4x4 configuration or even more. So actually what we provide to our customers is a turnkey solution. So we have a fully integrated platform. So for each different flavor of IPs composed of a scalable MAC subsystem, which contains some hardware accelerators and a full Wi-Fi protocol stack, which can run on a CPU. So any CPU can be used actually. It can be a CEVA DSP, but can be a RISC-V, an ARM, whatever. So it's connected to a modem subsystem. And here we propose two options to our customers, either a fully hardwired modem, so for low gate count, so low die size and low power consumption, or we have a more flexible solution, so a software-defined modem, which is running on a CEVA XC DSP, plus some hardwired accelerators, and which is particularly interesting for complex configuration, like access point with 4x4 MIMO capability or more. So all of that is integrated into a turnkey platform, which is completely scalable. Any processor can be used, and this platform is actually provided with a RISC-V processor as a reference, so that our customers really get a turnkey solution out of the box when they receive our IP.